So today we are going to learn about the sine law, and the sine law is a law that we use when we don't have a 90-degree angle. So what we're going to do first of all is we're just going to review our trig ratios with a regular 90-degree angle. So the first thing we're going to do is look at this example of A, and we are going to find out what is the sine of angle X. And all we know is that it's the opposite over the hypotenuse. So when I do that, I then go ahead and solve for x by plugging it into my calculator using my inverse function, and I end up with 35 degrees. Of course, that is the 8 over the 14, and I go ahead and plug that into my calculator. The second one is very similar to that. We're looking for, however, this time we're not looking for the degrees, but we're actually looking for the side, and in this case we're looking for the hypotenuse. So we know that the angle has been given to us. It's cos 40 degrees. Why is it 40? Because we know it's adjacent. If this is the angle here, the adjacent is the x, and the angle is not the x, that's the hypotenuse. So the angle is 40, the adjacent is 19, and the hypotenuse is of course x. So if I'm solving for that, I'm going to multiply x by both sides. That'll give me x on one side, and the other side will have the 19 divided by cos 40 degrees. When I plug that in, I end up with a 25. That is not using your second function, but instead that is just using your cos on your calculator. Therefore, this x is equal to 25. Now, we're also going to go ahead and use SOHCAHTOA to determine the length of BC. Now, BC is this right here. But of course, we can't solve for that right away because we don't have a 90-degree angle that is ABC. So instead, what we'll do is we draw a line down from A to D. We now have our 90-degree angle, and by doing that, we can first of all solve for AD. Once we have AD, which is the perpendicular height, then we can go ahead and solve for our BD, and we can also then solve for DC. Once we have both of those values, we can then determine the entire value of BC. So how do we go about that? Well, the first thing we're going to do is we're going to solve for X. Let's do the BD first, because that's pretty straightforward. So BD, which is X, we're going to call this X. X is going to be, well, we have an angle right here. It's sine 20 degrees. And we want to solve for the x, which is the opposite. So there's my x over here. My hypotenuse is going to be 12.5. And so when we solve for x, I'm going to actually go ahead and multiply the 12.5 times the sine 20. Now that is just algebra, and that should be something that you can manage. We're just going to multiply both sides by 12.5, and you end up canceling these out, and you end up with x. X in this case is going to equal 4.275 centimeters. Now that I have that, I can now, and by the way, x is BD. Remember, we've talked about that before. BD equals 4.275 centimeters. The next thing I'm going to do is I'm going to look for AD. Because I have this now, we also have BD. I can use those values in order to figure out my AD. Now, AD looks pretty straightforward. All I need to do is use, again, this angle. So I'm going to go up here to the top, and I'm going to go cos this time, and of course cos is because the adjacent is what we're looking for. So I'm going to erase all of this and start again. We're looking for this value right here, which is adjacent to this angle. So we have cos 20 degrees, and that of course is the adjacent, which is h, and the hypotenuse, which is 12.5. Once we have that and a 0, we'll put the 0 in there as well. Once I have that, then I can go ahead and solve for h. Again, I'm going to multiply both sides by this 12.5. I'm going to do it here, and I'm also going to do it here. So when I get that, I end up with h equals 12.50 cos 20 degrees. After I do that, I just go ahead and plug that into my calculator, and I end up with a number of 11.746 centimeters, which is also known as AD, which is just from the two vertices, 746 centimeters. Now that I have that, now I have this value right here. This is the one that's now in green. What do I need to do? I need to find DC. Well, can I do that? And yes, I can. Notice that we've been given this angle of 55. So what I'm going to do is I'm going to recognize that opposite to it, adjacent to it. Actually, I'm going to take that out, and I'm going to say, here's our new value we just found on the h. We then can go ahead and calculate this value here by using tangent. So tan, in this case, tan 55 degrees. That would be opposite over hypotenuse. Or we can go, we can call it y. Maybe that's what we'll do. Instead of yellow, we'll call it y. We'll go y opposite over h, which was the value that we just found on our AD, which is 11.746. Y, of course, multiply both sides by 11.746, and I end up with 11.746 tan 55 degrees, and that equals 16.775. DC therefore equals 16.775 centimeters. Now, what do I need to do? I needed to find, initially in the question, it asked me for the length of BC, which of course is this whole bottom. So now all I need to do is I need to add my BC equals the x plus the y, or the BD plus the DC, and that will be 4.275 plus 16.77. Oopsie, we'll just move that over a bit. 775, which equals 21.05 centimeters. And that is the end of the first page.